Hello, today we are looking at our packet number 8 for pre-algebra. Our first page says Ryan agrees to care for his neighbor's sloth. How fun would that be? Well, they go on a 2-week vacation. His neighbors give him two options for payment. With plan A, Ryan would get $2 on day 1, $4 on day 2, $6 on day 3, $8 on day 4, and so on. With plan B, Ryan would get only 2 cents on day 1, 4 cents on day 2, 8 cents on day 3, 16 cents on day 4, and so on. Which plan should he choose? How much more money will he make with that plan? So we want to figure out how much he makes with plan A, how much he's going to make with plan B. So we have 14 days. They're going on 2 weeks vacation. So there's 14 days. So I'm going to write out 1 week and then 2 weeks. Because he's going to do it every day for 14 days. With plan A, he gets $2, and then $4, and then $6, and then $8, then $10. So we're seeing that he's increasing by $2 every day. So you're going to complete the amounts that he gets every day, and then we have to add them all up to get the total amount that he's earned for plan A. So you want his total amount for plan A. Now let's look at plan B. We have to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. The first day he's only getting 2 cents. Second day he gets 4 cents. Then he gets 8 cents. So we're not just increasing by the same amount as we did up here. In plan A, he increased by $2 every day. But for plan B, he's multiplying by 2 every day. So 0.2 times 2 is 0.4. 0.4 times 2 is 0.8. On day 4, he gets 16 cents. So then day 5, if we multiply that by 2, he gets 32 cents. Then on day 6, he would get 64 cents. And then 64 cents times 2 is now $1.28. And you're going to keep increasing by multiplying by 2 for all of plan B. And you want to add them all up to get a total of what he's going to have by the end of 2 weeks. So you're going to see a difference. There's going to be a healthy difference in the amount that he earns with plan A and with plan B. We have 2 questions to answer. Which plan should he choose, and how much more money will that plan make? So take the bigger number that he's going to get and subtract out the smaller number to see how much more money he makes. Let's look at our next page. All right, so we have the numbers 1, 2, 3, 4, 5, and 6. We're going to arrange them in the circles below. You may use each number only once in each of the triangles, and all of the numbers must be used. No doubling up. Use all 6 numbers in each of the 6 circles. The sum of each side of the triangle should be the same. And you're going to find 4 different solutions. Now here's the kicker. Each solution will total a different sum. So let's do one together. So I'm going to put my biggest number here with the 6. Then I'm going to say 5, 4. I'm putting my big numbers on the ends. So I see 6 and 5 give me 11. That's a really big number. So I'm going to put a really small number in between them. So 6 plus 1 plus 5 gives me 12. So I want my other 2 sides to equal 12. 6 plus 4 is 10, plus 2 equals 12. 5 plus 4 is 9, plus 3 equals 12. So each of my sides equal 12. I've used each number one time. 1, 2, 3, 4, 5, 6. So I've already shown us how to do it with the sides equaling 12. None of the other triangles will have sides that equal 12 because they are going to be a different sum for each of the other triangles. Only one's going to equal 12, and then the other ones will equal other amounts. So you're going to want to play around. I had to do a lot of erasing as I was filling this out. It's a lot of trial by error on where to put your numbers. So each side equals the same amount, and that total sum does not equal a total sum that you've done in a different triangle. So again, there's a lot of trial and error that you do with this one. I did have to erase a bit trying to find some of these, but it can be done. We have our 5-card challenge. It's kind of an easier one with the numbers we have. I've been seeing lots of good equations people are coming up with. I say you should try to challenge yourself and see how many you can find. Our next one is our pattern blocks. So pre-algebra needs to complete the whole table. So let's do the first 4 figures together and see if we can find some patterns to follow. In our first figure, there's 1 yellow, 0 blue, 1 total black. Second figure, we have 5 yellows, 4 blues for a total of 9. Then third figure, we have 9 yellows, 16 blues, for a total of 25. In our fourth figure, we have 13 yellows, 36 blues, and 49 total. So let's see if we can see some patterns going on to help us figure out what we're doing. When I look at this, I'm looking at the yellow column, and I see go from 1 to 5, 5 to 9, 9 to 13. I'm increasing by 4 every time. So I can easily fill out the yellows. Then I look at my blue blocks and I say, I see some of Mrs. Gambino's favorite numbers. I'm looking at 4, 16, 36, and I see that there are some perfect squares there. So if I look at let's do it in a different color. If I look at figure 2, 4 is 2 squared. 16 is 4 squared. 36 is, not 8, my bad. 36 is 6 squared. So it goes to figure that the next one would be 8 squared. Then I look over at my total blocks and I see, more of my favorite numbers. 1 is 1 squared. 9 is 3 squared. 25 is 5 squared. 49 is 7 squared. So it goes to show 1, 3, 5, 7, 9 squared. So we can find those patterns with the numbers that we know how to work with. I love the perfect squares. I love that we keep seeing these perfect squares showing up. It's always good to know your perfect squares because we use them a lot in math. So follow those patterns all the way down to the 8th figure. We do not need to do the geometry section, so don't worry about that. We do not have a question being asked of us, so we have no answer to give. Just complete the table for figures 1 to 8. Our next page, we have a cube. Its volume is 729 feet cubed. Answer the questions for your class and show your work. For pre-algebra, we need to say what is the surface area of the figure. The formula for the surface area is 6 times side squared, because we have 6 sides on our cube, and each side we need to know the area for that side. And to know the area of a square, we do side times side, because the sides are the same in a square. Length times width, they're the same. So it's side times side, and then there are 6 sides, so we do 6 times side, the side squared. So how do we know what the length of a side is? They don't tell us that, but they do tell us the volume. To use that information, we need to know that the volume of a cube is is the side cubed. And we know our volume is 729 feet cubed. That equals side cubed. So we need to figure out for one side what one number multiplied it, cubed it, multiplied by itself 3 times is going to equal 729. So if you find out 729 equals side times side times side, if you could figure out what that side is, you're going to use that in this formula. You're going to square that side and then multiply it by 6 to put your answer down below. You're going to want to, when you do this one, it's going to really help you on the next page. Let me show you why. So let's turn to our next page. And we see we have lots of those figures that we need to find the volume for. So for pre-algebra, you need to do 3 of them. You can challenge yourself to do more, and it will give you really good help, those of us that really needed to work on some geometry skills. So this is one of those things that's really going to help you with that. I am going to go through and I am going to give you the formula for each of these figures. Mr. Schultz has already plugged in some of the lengths and widths for you, or the radius and the height, to get you started to be able to solve these. So for our rectangular prism, our formula is the length times the width times the height. We know that the volume is 144. So volume is length times width times height. We know that we could use a base length of 12 and a width of 3. So I can fill those numbers in and say 12, the length of 12 times the width of 3 times the height equals my volume of 144. Now I just have to use my opposite operations to get the height by itself. So if I'm multiplying by 3 and multiplying by 12, if I want to get height by itself, I'm going to do the opposite, and I'm going to divide out the 12 and divide out the 3 on both sides, and I'll be left with just my height. For our cube, oh, interesting, the volume of this cube is 729, which we just did on the page before. I know that my formula is side cubed, or side times side times side. So I'm not going to give us any base length, width, or height for this one, but if you did the page before, you know what that side number would be to equal a volume of 729. So that's kind of an easy one for us to fill in. For our triangular prism, the formula for the volume is 1/2 the, instead of saying base, we're going to say length times width times the height. So the length times the width times the height. So he gives you the length and the width just like he did for the rectangular prism. You just need to do the opposite operations to find that height and make sure that you know what to do with that half. If we are multiplying by half, the opposite would be dividing by half, which is multiplying by 2. For our right pyramid, the volume is length times width times height divided by 3. And he's telling you that you can use a length of 16 and a width of 12. Doing our opposite operations with the multiplying and dividing, you'll be left with just the height. Our cylinder's formula is pi times r squared times the height. And he's telling us that r, the radius, is 3. Again, plugging that in, doing your opposite operations with the volume that's given for that shape, you can find your missing height. For our cone, the formula is pi times r squared times height divided by 3. And we know our height is 2. You can do opposite operations to find the missing radius. And our formula for the sphere is 4 divided by 3 times pi times r cubed. And if you equal that to the 5,575 of the volume, do your opposite operations and you will be left with just the radius. Again, we have to do 3 of them. One of them is going to be really easy if you've already done the page before. So pick 2 more to do. If you want to challenge yourself to grow some more with your learning with geometry, do some more, but you have to only do 3 of them. Our next page is area and perimeter. Oh, I did not erase all of my dots. Let's erase those. All right, so the first thing is the area of the full figure. So to do this, I found the area of my full rectangle, and then I subtracted out what I didn't want. Well, actually, no, that's not how I did it. That's how some other people did it. The way I did it, let me show you how I did it, was I made 2 rectangles, the big rectangle and the small rectangle. So I know that if this full side is 20, the smaller side is 15, so that side would be 5. And if this side is 13 and the full side is 30, that left me with 17 here. So I did 17 times 5, and then I did my full 30 times the 15. And I added those 2 together to get the area of the full figure. You could do taking out this section, but don't forget to subtract that away. If you do 20 times 30, you have to subtract this section away. That 5 times 13, you need to take that part away. So that will give you your total amount. Then we need to find the area of our white. So the area of the white, we've got 20 centimeters and 10 centimeters. So you want to find your white area, and you're going to subtract it from your total area. And what you're left with will be your shaded area. So you have to find the area of the full figure, find the area of the white figure, subtract out, take away the white shape, and you're left with just the shaded area. Our next page is our Fibonacci page. So one interesting thing about these Fibonacci numbers is that the numbers are not random. In addition to being the sum of the 2 previous numbers in the sequence, like we saw in our last packet, a number n is part of the Fibonacci sequence if and only if, when we take that number and we square it, multiply it by 5, and either add 4 or subtract 4, our answer is a perfect square. Oh, there's those perfect squares again. So we're going to follow the directions for each column to fill in what we know. So for this, for the first one, I just want to move it up just a little. For this first column, below are several Fibonacci numbers. We know that they are Fibonacci numbers. Write each expression above, which expression above applies to it. So if we do this, or if we do this, one of those is going to give us a perfect square. So I'm going to take the 1, I'm going to plug it in for x. So I'm going to do 5 times 1 squared. I do plus 4. So 1 squared is 1, times 5 is 5, plus 4 equals 9. 9 is a perfect square. So I know that the plus 4 will give me a perfect square. So now I'm going to look at number 2. I'm going to look at 2. And I'm going to plug that in, and I'm going to say 5 times 2 squared. So 2 squared is 4 times 5. 4 times 5 is 20. Then if I add 4 to it, I would get 24. 24 is not a perfect square. But if I subtract 4 from 20, I get 16. 16 is a perfect square. So I know that I would want to use the subtracting equation to make that work. So you're going to do the same for the rest. Figure out if you add 4 or subtract 4, which way will you get that perfect square? In the second column, there are several numbers that we need to determine, are they a part of the Fibonacci sequence? Is it a Fibonacci number? So we're going to use these two equations, and we're going to see if we get a perfect square. Now, the easy way to do this is you're going to be getting some big numbers. I have perfect squares memorized only up to a certain point. I don't know all of them. So to figure out if a number is a perfect square, if you don't know, you see what the square root is. If there's a whole number is the square root, then it's a perfect square. If the answer to the square root has a decimal, it is not a perfect square, so you know that that equation doesn't work. Here's how it works. We know we're going to do 5x squared. So I'm going to put 12 in. 12 squared is 144, times it by 5, and I get 720. So that equals 720, and I need to add 4 or subtract 4 to see if I get a perfect square. So 720 plus 4 is 724. When I do the square root of that, it is not a whole number by itself. 720 minus 4 is 716. When I do a square root of that, it is not a whole number. There's a decimal. So no, 12 is not a part of the Fibonacci sequence. When I look at 13, I know it's 5x squared. So that would give me, if I put a 13 in, I square it, times it by 5, I get 845. Now I want to add 4 and subtract 4. 845 plus 4 gives me 849. I take the square root of that. It is not a whole number. 845 minus 4 gives me 841. I find the square root of that is the whole number of 29. So yes, it is a Fibonacci number. So you're going to do that with each of the numbers below. You're going to plug it into the 5 times that number squared, and then you're going to add 4 and subtract 4, finding their square roots. If it is a whole number, like this one, then the answer is yes, it is a Fibonacci number. If it does not work and you have 2 no's, it is not a Fibonacci number. In our last column, it says select 3 positive integers not already listed on this page and show how you can use the expressions above to determine if it is a Fibonacci number. You can use small numbers, you could use big numbers, but you're going to want to show what it is adding and subtracting by the 4 and telling if it is or is not a Fibonacci number. So for example, if I used the number 4, I would do 5x squared gives me 4 squared is 16 times 5 is 80 plus 4 minus 4. So 80 plus 4 is 84. 80 minus 4 is 76. When I find the square root of each of those, they are not just a whole number. So 4 is not a Fibonacci sequence number. So I gave you 1 there. You need to do 2 more telling me if it is or is not a Fibonacci number. Let's look at our next page. Is our polynomial page. We know how to do those. And the last page is a logic page. So let's look at how we solve these logic pages. What you're going to do is you're going to get the first section, you're going to have to see what we did, try to figure out how we manipulated the numbers, and you're going to want to manipulate the numbers on the other side in the same way. So if we know to go from 3.6 to 7.2, we multiplied it by 2. So we want to do that on the other side. We want to multiply by 2. To go from 64 to 8, we took the square root of 64 and we got 8. So we need to do that here, and we want to find the square root of 121. So each line item is going to be a different type of math that we have to do. You have to figure out what it is that we're doing in the first section so you can do it in the second section. Yes, I know that these lines are very long. No, we do not have to do multiple things there. It's just one answer on each line. I do want to point out this one. Several people who've been turning into me have missed what it is that we did to go from 18 to all of these numbers. And I want you to notice that 18 is one number, 27 is one number, and we have all these smaller numbers next to it. Notice what kind of numbers we have. 1 and 18, 2 and 9, 3 and 6. See if you can find that same kind of pattern for the 27. Hint, hint, think factor buddies. And our bottom one, there are 3 of something that equal a yard. So if we have 5,280 of something, what would it equal? So we need to think of our conversion tables. What do we have 5,280 of? What does that equal? We have the word yard here. We are going to have a word there, not a number. With that, we are done with packet number 8. Have fun working on your math. See me if you continue to have questions, and have a wonderful day.